Hello students, today we are going to see three different concepts. First one is quantifier and quantified statements. What is called quantifiers? When the statement is called quantified statements. See, a quantifier is, for example, this is denoted by, it is called for all, and this symbol is there exist. In one statement, if one statement is given, we are going to verify that one for the all the given objects, otherwise for all the given values. For example, A is given a set 1, 2, 3. First of all, a statement will see x plus 2 is greater than or equal to 3. This is a statement is given. We are going to see whether quantified statement, we are going to see whether first one, if x is 1, 1 plus 2, 3, 3 is equal to 3, this is correct. If x is 2, it is greater than, that is also correct. If x is 3, 3 plus 2, 5, greater than or greater than 3. Okay. For all the value of a, this statement is correct. So this statement can be written, listen, for all values of x belongs to a, x plus 2 is greater than or equal to 3 is a true statement. The same one, suppose, consider the same a, 1, 2, 3. These are the values are given. Now, the statement is x square is equal to 9. First we will see 1. It is not true. 2 square is 4. It is not true. But at least for one value, 3 square is 9. At least one value it is equal. So there exists one x. At least one x is there in A to satisfy this condition. So in that condition we will use the symbol there exist. It is a, these two are called, the for all is called universal quantifier and there exists is called existential quantifier. So using this one, we can see one or two, we can discuss the sum for the example. Here one set is given. Set A is 1, 2, 3, 4, 5, 6, 7. It is our universal set. So first one we are taking, there exists x belongs to A such that x minus 4 is equal to 3. There exists, whether this statement is true or not, we have to see. If the statement is true means in the set A, at least one value should satisfy because it is given there exist is given. Therefore, first I will see 1 minus 4 is minus 3. No, but one number is there. See, if you take x is equal to 7, 7 minus 4 is equal to 3. So one number is satisfying this one. Therefore, so listen, if x is equal to 7 satisfy the equation, x is equal to 7 satisfy the equation means the given statement is true. The given statement is true. Therefore, the truth value is t. Truth value can be written as t. Now listen, see the second one. See the second question, for all x belongs to A. For all. For all means each and every element of A should satisfy this equation. Then only it is true. Is greater than or equal to 3. First x value is 1. First x value is 1. x value is 1 means 1 plus 1 2 is not greater than or equal to 3. So the for all cannot be used. So it is not true for x is equal to 1. Therefore the statement is false. So the truth value is f. See the third one, x belongs to a. 8 minus x is always less than or equal to 7 for all. Listen, for all is given, for all x, listen, condition is given, x 8 minus x is less than or equal to 7. Condition is for all. Now we are going to see first value is 1. 1, 8 minus 1, 7. Correct. Second value is 2. 8 minus 2, 6. Okay, less than or equal to all the values 3, 4, 5. Take any value, this statement is true. So all the values it is satisfying. That's why we can say this statement is true. So the truth value is T. The fourth one, there exists a belongs to, x belongs to a such that there exists, listen, there exists x belongs to a such that x plus 8 is equal to 16. So a value take 1, it will not satisfy, 2 will not satisfy. 7 plus 8, 7 is the greatest number in the set. 7 plus 8 is 15. No value in the set A is not satisfying this one, so the statement is false. So the truth value of this statement is F. So clearly you should understand one thing, for all it is a universal quantifier. Universal quantifier means from the given objects set, each and every value will satisfy the statement, means we can use for all. If at least one value is satisfying the statement, we are going to use there exist. Another one simple concept we are going to discuss now, that is dual. What is dual statements? Here, if two statements are connected by and or. Two statements are connected by this one and or. Then the dual statement is nothing if you get a new statement by interchanging and by or and or by and. You are just going to interchange and by or by and. And next one, the tautology we used to write T, contradiction we will write by C. In the dual statement, tautology will convert, we can interchange this two also. Tautology will convert to contradiction, contradiction will convert to tautology. That means the interchanging of and to or and or to and. Another one, the tautology to contradiction, contradiction to tautology. This is a concept. Now another one, this dual statement, it will not affect the negation. There will be no change in the negation. Negation will be as it is. So we'll consider, for example, the last line it is given clearly. See, the P or Q, its dual is P and Q. So see the next one, T and T or P, its dual statement is T will go to C, it will go to R and P, contradiction. See the last one, T is converted to this one. So dual statement. First one, quantifiers we have seen for all and there exist. Next one, dual statements. Now listen, now we are going to see the sums based on this one. See this question, find the dual of each of the following. Each and every one we have to find out the dual statement. See the first one, its dual statement will be P. First one, listen, P and will go to R Q. And R will go to and R. This is the answer for the first one. See the answer for the second one. You just consider the second one. In the second one, this is a statement it is given. So T will go to C, contradiction, or correct. So disjunction will go to conjunction, and P within bracket P is there, and here R means R will go to and Q, this much. Now I already told you the dual statement, it will not affect the negation. For example, the third one, how it will come, P as it is and will go to R. Negation of Q as it is, negation of Q. R will go to and within bracket P or Q and negation of R. So it will not affect negation. Listen, see, P and R. There will no change in the negation. So only in the dual statements we are going to interchange and to R and R to and tautology to contradiction to tautology. It will not affect the negation. Now another one, negation of the compound statements. What is a negation of compound statements? Suppose two statements are there. Its negation we have to find out. So listen, negation of the compound statements we have to see. Before go to the negation of compound statements, we will just discuss one or two sums over here. Listen now, A is a set. There are two sums from the exercise I have taken. A is 3, 5, 7, 9, 11, 12. These are the values. What is the truth value we have to find out? Truth value, I have written the notes. Listen now. First A is given. First one, the statement is for all x belongs to A such that x minus 8 is equal to 1. Whether that statement is true or false. What is the truth value we have to decide. Now listen, see this one, this statement. See the first statement. This is a statement is given. First I will see in this one, x minus 8 is equal to 1. That more, if we take 9 minus 8 is equal to 1. So one number is satisfying. From the universal set, from A, one number is satisfying the equation. So we are writing x is equal to 9 satisfy the equation. So the statement is true. Because the statement itself it is given. Not for all the value. There exists means at least one value satisfy the equation. We can say it is true. So true means truth value is T. See the second sum. For all x belongs to A, x square plus x is an even number. X square plus x is an even number. See the condition, x square plus x. This number should be even, but universal quantifier for all. So first I will take 3. 3 square is 9. 9 plus 3, 12. So it is a even number. It is true. 5, 25 plus 5, 30. That is a even number. That is also true. 7, 49 plus 7, 56. That is a even number. 9, 81 plus 9. That is 90 even number. 11, 121 plus 11. That is 132. It is even number. 12 means 144 plus 12, that is 152. So each and every value of A All the value of A is satisfying this equation. That's why we will say this statement is true for all the values, not a single value, for all the values the statement is true. That's why I have written the statement is true. Therefore, the truth value is T. The same one, see the third one. There exists means it is enough to prove for at least one value. X belongs to A such that x square is less than 0. X square is less than 0 means we have to say this is a negative number. Square of the number is negative, we have to say. Can you find out any number from A? 3 square is 9, positive. 5 square is 25. Square of here, there is no value from A satisfying this condition. Therefore, no element of A satisfying this condition. The statement is false. So, the truth value is F. By mistake, I have written T. The truth value is F. Got it? Listen. Now, the same one. See this question. Write the duals of each of the following. So, duals concept is simple. We are going to write AND to or to AND. So, 2 or 3 sums I have discussed here. You just here, you see the second one. One statement I have taken and we have discussed here. Listen now. First, it is a given statement. In this statement, P, R is there, it will be AND, Q and R. This is a statement. Now see the next one. Second one. See, wherever R is there, we have converted that one to AND. AND will go to R. See the third one. C will convert to T. R will go to AND. Everything as it is. So this sum I have taken, you should know the dual will not affect the negation. Negation acts as it is. Negation of P. R will go to AND. Negation of Q. First bracket. Then AND will go to R. Then negation of R. Or yes will be yes. Sorry. Yes, big word S. There is no change at all. So, I hope everyone understands these two concepts. Now, one important concept we are going to discuss, that is converse, inverse and contrapositive. Converse, inverse and contrapositive, that is a concept I have taken now. You just see what is called converse, what is inverse. We know from the lower class, every theorem, converse, a theorem will be there, its converse will be there. So, if two lines are parallel, then alternate angles are congruent. It is a statement, conditional statement, if then. So, what is a converse? Converse means if alternate angles are congruent, then the lines are parallel. So, in this case, so this condition is if then. If lines are parallel, then alternate angles are congruent. Okay. First one will take P, the lines are parallel, it is P, and alternate angles are congruent is statement. So it is conditional statement if then. For the conditional statement, it is a statement. Then what is a converse? Converse means we are going to write from Q to P. That means if alternate angles are congruent, then the lines are parallel. We are taking now it is converse. Okay. What is inverse? Inverse is the statement is P to Q is a statement. It is a statement. If you know the statement, so converse we have seen Q to P. Next, I want to see inverse. Inverse means nothing. Negation of P tends to negation of Q. What is P? P means P I have considered if two lines are parallel. Negation of P means if two lines are not parallel, then the alternate angles are not congruent. This is called inverse. Then contrapositive means negation of Q to negation of P. That means if the alternate angles are not congruent, then the lines are not parallel. So this is a concept, it is called, this is a concept converse, inverse and contrapositive. So first you should know the statement. If you know the statement, then only we can go. See, P to Q, this is a statement. First statement you have to write, first step. So statement means it should be in the form if then. It is P, another one is Q. First statement we will write. So conditional statement. Next one, what is converse? Converse means Q to P is converse. Inverse, negation of P to negation of Q, and negation of Q to negation of P. So we will go for some one or two examples over there. You see here one statement is given. From this statement, in this statement I am going to discuss about first one. See, if a function is differentiable, then it is continuous. First of all, I am going to decide what is P. P is if a function is differentiable, that is P. That is P. Then it is continuous, it is Q. So from this one, for me, the statement is P to Q. That means if a function is differentiable, then it is continuous. Okay. That is the statement. Now, first in converse I have to find out. Converse means what is that one? Q to P. Q to P means continuous will come first. If a function is continuous, then the function is differentiable. We are writing. If, see, converse, if a function is continuous, then it is differentiable. You are writing. It is an important concept, my dear. Listen, next one. What is inverse? Inverse means negation of P to negation of Q. Negation of P means it is P means a function is differentiable. Negation of P is not differentiable. So if a function is not differentiable, then it is not continuous. So if a function is not differentiable, not, because negation has come, that's why. Now contrapositive. The contrapositive is negation of Q to negation of P. So Q is continuous. Negation of Q is not continuous. The function is not continuous. If the function is not continuous, then it is not differentiable. This is the first sum. Next concept, listen, next sum, if it rains, then the match will be cancelled. If it rains, the match will be cancelled. P, if it is rains. Q, match will be cancelled. If it is rain, this is a statement. Now, in this statement, listen, P to Q, it is a statement. Next, negate, converse, Q to P is converse. So Q to P is converse. What is a converse? If the match get cancelled, then it rains. It rains. Now inverse means negation of P. Actually, what is P? It rains. Negation of P is it does not rain. So it does not rain, then match will not be cancelled because Q is match is cancelled. So it will not be cancelled. Then from here to there, that is contrapositive. the match is not cancelled, then it does not raining. This is a concept over there. Now, so the same one, the exercise one sum is there. From the exercise, suppose the condition is given. Suppose the conditions are given. Exercise question number 4, the first one, I'm just, instead of giving the statement, if the condition is given, my P is, listen, P is first one. This one is P. It is Q. The statement is, if x less than y, then x square less than y square. This is a condition. Statement is P tends to. Okay, it is a statement. Now we have to see one by one. Statement we know, converse. Converse means it will be, Q will be first, Q to P. So if x square less than y square, then x less than y. Yes. Now, one important thing you have to take care, whenever we are comparing two number x and y, there are three. It will be greater, otherwise x will be less, otherwise both are equal. These are the three concepts. Here, less than, it is not less than means these two are possible. It may be greater than or equal. So, listen, that's why in this concept you see the concept. I am using, listen, yes my dear. Now listen, see the sum. First we have completed the converse, then come to the inverse. This inverse part, negation of P to negation of Q. Actually, P is x is less than y. P is this one. What is negation of P? X and y not less than. Not less than means it will be greater than or equal to. Then it is also P is negation and Q's negation will be x square less than y square is Q. So x square greater than or equal to y square, it is negation. So then contrapositive is just opposite to this one. The inverse converse of the inverse is contrapositive. So today, first concept we have discussed. The first concept, the quantifier. The statements is quantified statement means for all is this universal quantifier, and existent quantifier is there exist. Here, suppose one set is given, otherwise some objects are given. Every object, each and every object should be satisfy the given statement, then only we can use for all. There exists means at least one given value or object is satisfying the equation given statement, then we will go for there exist. Next, dual statement. The dual statements we have seen, it is just interchange of R to and to R, tautology to contradiction, contradiction to tautology. Bas. So, and very important one, it will not affect negation. That concept we have seen. Now, next one, the important concept, converse, inverse and contrapositive. First of all, the statement should be if-then statement. That means conditional statement in this statement. So, we will say converse means we are going to say in this way, Q to B. If Q, then P. Next, and inverse is negation of P and negation of Q. In the statement, we can use not. Suppose x is a even number, negation is x is not a even number, we will write. But if the condition is like this way, greater than means it's a negation, it will be less than or equal to y. So negation will be. So we have used that also. Thank you.